Welcome to solverfy.
Hi, in the given problem, initial speed given to the rocket in upward direction is Vi is equal to 80 meter per second, and acceleration provided is A is equal to 4.00 meter per second square. The maximum height raised under this accelerated motion is h1 is equal to 1000 meter, after which the engine goes off and then the retardation will be g is equal to minus 9.8 meter per second square. The rocket will keep on moving up until its velocity becomes 0 at the topmost point. So now, in the first part of the problem, we have to find the total time taken by the rocket in this upward motion above the ground. So, for this, first of all, we will find the time taken during accelerated motion. So, for the time taken during accelerated motion, we will use third equation of motion, which says final velocity, square of final velocity Vf square is equal to square of initial velocity Vi square plus 2a into h. For Vf, this is unknown. For Vi, this is 80 to the whole square plus 2 into 4 for the acceleration into 1000 for this h1. So it becomes 6400 plus 8000. Hence, it comes out to be Vf square equals to 14400. So finally, Vf is equal to 14400 square root, means it comes out to be 120 meter per second. So now, using first equation of motion, which says Vf is equal to Vi plus a into t1. Let this time in the accelerated motion is t1. For Vf, this is 120 meter per second. For Vi, this is 80 meter per second. For acceleration, this is 4 meter per second square. T1 we have to find. So this 4 into T1 comes out to be 120 minus 80, which remains 40 meter per second. So T1 here comes out to be just 10 seconds, the time taken during the accelerated motion. So now, for retarded motion, the final velocity during accelerated motion means this Vf will serve as initial speed for the retarded motion. Here, if we say this is the ground, this is Vi over here, then at the height of 1000 meter, it becomes Vf, and then for the retarded motion up to the maximum height, this is capital Vf, which is actually 0. And for this retarded portion, this Vf behaves like initial speed. So for the retarded motion, using again first equation of motion, Vf, capital Vf equals to Vf, small vf, plus g into t2. For Vf, this is 0. For Vf, this is 120 minus 9.8 into T2. So this T2 comes out to be 120 by 9.8 seconds, or we can say this T2 is equal to 12.24 seconds. So total time taken by the rocket in upward journey will be given by T is equal to T1 plus T2, means 10.0 plus 12.24, or we can say this time comes out to be 22.24 second, and it becomes the answer for the first part of the problem. Now, in the second part of the problem, we have to find the total height raised by the rocket, and that will be equal to h1 height raised during accelerated motion plus h2 height raised during retarded motion, and we know this is 1000 meters, so we have to find this h2 only, for which we will use second equation of motion for the retarded portion of the motion. So it becomes h2 is equal to vf, the initial speed vf. The final speed for the accelerated motion will behave like initial speed for the retarded motion. So vf into t2 plus half g t2 square. So this h2 here will become 120 into 12.24 minus, as g is negative, into the square of this 12.24. So here it becomes 1468.8 minus, here it becomes 734.11. So it comes out to be 734.7 meter. So the total height raised by this rocket in upward direction is 1000 plus 734.7 meter, or we can say this answer for the second part of the problem comes out to be 1734.7 meter, or approximately we can say this is 1735 meter, the answer for the second part of the problem. Now, in the third part of the problem, we have to find the speed with which this rocket will hit the ground again. For that, we will just use the conservation of energy. Kinetic energy at the ground level, when the rocket will hit back the ground, will be equal to its total potential energy at the highest point, means mgh. So using that, this v square, or we can say this v, will come out to be square root of 2gh, or this is 2 into 9.8 into 1735. So finally, this v will come out to be 184.4 meter per second, and it becomes the answer for the third and last part of the problem. Thank you.